A few years ago, I did some engineering work with a nonprofit that was building AI tools for conservation researchers. The premise of that org was that we could build models that would let researchers identify, classify, and count endangered species. But here's the issue with that concept. It works great if the species in question is threatened or only mildly endangered, because there are still lots of images and videos and audio files that you can use to train your model. But if the species is truly on the brink of extinction, there may only be a few photos of that species in existence, or only a few audio recordings of its mating call, or only a few confirmed footprints or tracks, or there may only be one video ever taken of that animal and it was taken from a specific angle, often in terrible lighting. In other words, there's just not enough data to actually train a model to recognize or identify that animal. This is what the few-shot learning problem looks like in practice. It's you asking a model to learn and then be able to generalize from just a few scattered examples. And unfortunately, you're asking it to do something that you have no reason to think it's even remotely capable of. The few-shot learning problem is everywhere. You see it in medical diagnostics and in fraud detection. You see it when a manufacturing engineer tries to spot early signs of equipment failure, and when a cybersecurity analyst tries to spot a new malware strain. You see it in industrial thought monitoring and speech recognition, and crop disease detection, and even in astronomy. In the real world, you just don't always have massive labeled datasets. Sometimes all you've got is a handful of examples. But you still need to make it work. Enter large language models. LLMs have, in recent years, shown remarkable ability to learn from just a few examples. In this context, we'd call that few-shot prompting. You show an LLM a couple examples of a task, for example, and it can often then go and figure out how to handle new cases of that task on its own. But here's where it gets tricky. Most LLMs are designed for text, nothing else. So if you're dealing with sensor readings or time series data or any other kind of data type, you're in kind of uncharted territory. In this paper, the authors attempt to tackle this problem. They developed a system called HED-LM, Hybrid Euclidean Distance with Large Language Models. It's designed to optimize how you select which examples to show to an LLM when you're working with something like sensor data. Specifically, they used fatigue detection as their test case, just to have something tangible to apply this idea to. But the real contribution here is a methodology that applies to everything from classification to pattern recognition tasks to anomaly detection. On today's episode of Journal Club, we'll dive in and see what they did and find out if it actually works. If you're already subscribed to our email newsletter, then you'll be getting this episode in text and audio form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.